The goal of this video is to show you what happens when you put an outlier in a set of data, and again to show you one more time how an outlier will break the mean. It will make it incorrect, but it will not change the median, because that's what the median was designed for. The median was designed to handle any outlier. Alright, so let's take a look. This site allows me to grab a number, put it anywhere from 0 to 100. So you can look at anything. I'm just going to drag some out here. So I drag 1 out, and there's the median. Okay, the middle of the numbers, 46. Guess what? The mean is 46. If I add 46 and divide by 1, I get 46. Let's see if we can't make this a little easier. Let's go 40. Now I'm going to put this one at 50. Can you tell me ahead of time what you think my numbers will be? Hopefully you said halfway between 40 and 50 is 45. If I add 40 plus 50 up, get 90, divide by 2, I get 45. Let's put another number out. Let's do 35. Another number, let's do 55. Now notice I can keep this in the middle as long as I put dots equal distant away from my center. Let's put one right at 45. Now everything's nice and lined up. Now what I want you to watch is this. If I take this number and I start sliding it to the right, which makes it an outlier, which arrow is going to move? The green one or the blue one? Well, the median, remember, finds the middle number. Okay, the mean takes all the numbers values and adds them up. Look what happens. If I slide this over, all of a sudden my mean jumps to the right, because this is a much higher value and it pulls the mean to the right. So is this accurately showing the middle of all my numbers? Not really. The mean does not work right when there is an outlier. Now again, watch. Why hasn't this moved? Because the middle, I don't care how big this is. I don't care if it's here, 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 or the whole way off the screen. The median will always stay in the middle. That's why people created the median, to truly show a middle value when there is an outlier present. Alright, let's go the other way. If I drag my outlier to be lower, you got to remember, outliers aren't always bigger, they can be smaller. It drags my mean down. The median has not changed. No matter where this outlier goes, the median still does his job. But the more I drag this down, the more the mean gets pulled down with it. I want to just go through one more example. Imagine test scores. You have a 94, 96, 91, 99, and let's do a 89. Now the question is this: what does average do? It shows you the middle, or what happens most. Are you an A student? Look at this. You have a 94, a 96, a 91, a 99, and 89. Are you an A student? On average, are you an A student? The answer is yes. Now look at both averages. They both point towards the middle. They both show that you are an A student. Here's the thing. If you got a bad grade, or let's say you never turned a test in for whatever reason, and you get a 0, look what happens to your average. That means you're a C student. Does that really make sense that you're a C student when all you did was bad on one assignment? I don't know. I don't think. Typically, you're an A student. And again, the median, what it does is it goes right here in the middle. Now, what this leads into the discussion of is, which average should we be using for your grades? Do you know what average is currently being used for your grade? It's the mean average. We take all the points and divide them up by how many assignments you have. Is it fair to use the mean average? What if you miss an assignment? Is that fair to say now you're a 76? You're a C student versus an A student, what you typically do? it leads into the discussion of which average is best for which type of data or which type of numbers. The mean is good for when all of the data or numbers are close together. The median is good when you have outliers. You can have a number as far away as you want, the median still will find its middle. So I hope this is a better visualization of what an outlier actually does. It makes the mean turn bad, it's broken, but it lets the median continue to do what it does. I forgot something and I wanted to show you one more thing. There is another way that you can tell that there's an outlier. I'm going to drag my numbers out here. Not only could you visually see it, like in this example, you can visually see when there's an outlier. What if you can't visually see the numbers? What if you just have a random list of numbers, you found the mean, you found the median, and then somebody says, is there an outlier? There is another way to prove that there is an outlier. I want you to watch what happens. If I don't have an outlier, what do you notice about the location of my arrows? Are they close together or are they farther apart? Hopefully you say that they're closer together. So when I look at this, the numbers should be close in value. 45 is pretty close to 45.2. There's not that much of a difference. So that should make sense. Hey, these two numbers are basically doing the same thing. They're showing me the middle. The mean is working because all of the numbers are close together. So I'm allowed to say, if the mean is close to the median, there must not be an outlier. Okay? Let me make it just a little more dramatic, so to speak. Are my numbers close together? Median is 7, mean is 6.8. Yes, they are close together. So watch what happens. I'm going to put in an outlier. Now we know the mean is not going to work. It's going to shift to the right. So we know the mean's not accurate. But look at the difference in the values. Is 7 close to 24.2? No. So if you don't have any pictures and you just have the answers, you should be able to say, Mr. Long, there has to be an outlier, because if there is an outlier, these numbers are far apart. If there wasn't an outlier, these numbers would be closer together. So that's just another way to prove that there is an outlier. If your two averages, mean and median, are not close in value.